Welcome. I'm sure you remember from just a few years back these pictures of sunspot numbers crashing over the next few decades to very low numbers indeed, and the corresponding total solar irradiance also falling such that the Earth was going to cool. But equally, I'm sure if you've been following my YouTube channel or the Twitter channel, then you will see that the sun has been very active recently, in fact at record high levels. So what really is going on? I think it's time for an update on the status of the grand solar minimum hypothesis. Let's first take a look at the predictions from the grand solar minimum. First, they claimed that solar activity would fall. This is a plot from Zarkova 2024 where it showed the sunspot numbers dropping significantly, solar cycle 25 being significantly smaller than solar cycle 24, and the next two cycles basically being non-existent. And they also predicted that the maximum of the cycle will be something like July of 2023 to June of 2025. Now, the reason why there's such a large error on this is that the scale on the bottom of this plot is non-linear. The gaps between the various dates is not the same for each one, so it's very difficult to tell where one date begins and the other date ends. I think that's probably deliberate. The second major prediction was that the Earth will cool. With the falling in the sunspot number and the total solar irradiance, the amount of energy the Earth is receiving from the sun would fall, temperatures would fall correspondingly, and we get into a situation something like the Maunder minimum, where the Thames froze over and crops failed and people starved to death. So how are these predictions doing? Has solar activity weakened? We'll take a look at sunspot numbers and areas, flares and CME rates, total solar irradiance, and very importantly cosmic array rates, which has been something that people have been making a big thing about, and turns out there's a storm in a teacup. Well, has the Earth been cooling? We're going to look at global surface temperatures in the upper atmosphere, and ice loss rates. From a sunspot point of view, the numbers have increased quite significantly. This is solar cycle 24 on the left and solar cycle 25 on the right. And you can see solar cycle 25 has far outperformed solar cycle 24. If you look at the maximum daily sunspot number, that's the yellow points, solar cycle 25 had a record high of 290 so far. In fact, actually the other day it just passed 300, and the highest point that solar cycle 24 reached was 220. Similarly, if you look at the monthly sunspot number, that's the blue curve, we had a high during solar cycle 24 of 140. The highest point we've reached so far is 198 in solar cycle 25, and that was last month. I think there's every chance that that's not going to be the final highest value we get. So the takeaway from this is that solar cycle 25 is more active than solar cycle 24, and the GSM prediction has failed. We can look at sunspot area. I don't have the equivalent numbers for solar cycle 24, but they're quite modest. As you can see here, the sunspot area is well above 1,000. 1,000 is generally considered quite a large area. In fact, it went above 1,500 this morning. So we have a much larger area of the sun covered by sunspots. We're getting bigger sunspots more often than we did before. So again, solar cycle 25 is looking far more active. Well, of course, sunspot numbers are not the only measure of solar activity. What about flares? Let's take a look at C flares, that's the common flares, major flares, M flares, and X flares, the extreme events. This is the comparison for solar cycle 24 and 25. Solar cycle 25 is in orange and solar cycle 24 is in dark blue. And so far this cycle we've had 7,021 C flares in solar cycle 25, and that compares with about half that number at the same stage in solar cycle 24. During the whole of cycle 24 we had a grand total of 7,811 C flares, and we're already at 90% of that level after just 4.5 years. So it looks as though solar cycle 25 is going to outpace solar cycle 24 quite significantly in terms of C flares. Let's move on to M flares as the major category of flares. We've just had our 1000th M flare from solar cycle 25, shown here again in orange. And the total we got from solar cycle 24, the entire 10 years of solar cycle 24, was 738. So we've already outpaced solar cycle 24 by quite a significant margin. Overall rate to date, we're getting 3 times the number of M flares compared to the number of M flares during solar cycle 24. So it's quite safe to say that solar cycle 25 has already outpaced solar cycle 24. In X flares, this picture is similar. We've had 3 times the number of X flares to date that we had during solar cycle 24. We had 56 to date, and they are stuck at 19. So there's a factor of 3 right there. The solar cycle 25 total has outpaced solar cycle 24, 56 to 49, and that difference is only going to grow over the coming years. We can also take a look at coronal mass ejections. Here we have the same thing, but solar cycle 24 is doing better compared with solar cycle 25. Solar cycle 25 is outpacing it by about 30%, but overall we're at 60% of the total for solar cycle 24 already, and that means we're probably going to end up with something like 13,000 CMEs by the end of this process. So once again, even coronal mass ejections are outpacing solar cycle 24 ones during solar cycle 25 at the same stage. Well, total solar radiance is something that people keep on and on about, because that's the amount of energy that the Earth receives from the sun. And we can take a look at the data here. With the current data shows that solar cycle 24, which is the curve that peaked around about 2014, is well below the level of solar cycle 25, which hasn't reached its peak yet. It's about 0.32 watts per meter square above solar cycle 24. So once again, we are outpacing solar cycle 24 significantly with solar cycle 25. Now, a lot of people make a thing about the cosmic rays and say the cosmic ray level is still quite high, and therefore the sun's magnetic field is weak. Unfortunately, that isn't true. And it's during solar cycle 24, you can see with the dotted line here, the deficit from average for cosmic rays was about minus 2.5%. We're already at over 6% below average with solar cycle 25, and we haven't necessarily reached the minimum as yet. The stronger the magnetic field of the sun gets, the more cosmic rays are rejected from the solar system, and the lower the flux we get at Earth. And so we have a much lower flux than during solar cycle 24, so the sun's magnetic field is in fact stronger, despite what some claim. So let's draw some conclusions based on the data I've shown you about solar activity levels. The sun has been more active than at any time during the last 2 decades, and may well extend that to 3 decades if the activity goes up any further. Compared to solar cycle 24, the number of sunspots has increased, sunspot areas have increased, flares have increased, both C, M and X, CMEs have increased, total solar radiance has increased, and solar magnetic fields are stronger, causing cosmic ray fluxes to drop. The grand solar minimum hypothesis fails in its predictions of all these measurable activity parameters. So what about the Earth cooling? Well, this is a thing that Zarkova has pushed quite a lot, and she quotes Akasufu's paper to prove her point. She shows where we are at in 2015, this is when she did her paper, and shows a dot here well below the curve that the IPCC predicts, and she then mocks the IPCC in the usual fashion. So we'll take a look at what the real situation is and correct this point of view. Well, is the Earth cooling as they predicted? Well, here's the plot of the global temperatures over a year period. Does that look like a cooling trend to you? Sure doesn't to me. And then in particular, the last year has been amazing. It's jumped up to nearly 1.4 degrees centigrade above the 20th century average. Now, that is for land and ocean. If you take land temperatures only, it's more like 2 degrees centigrade. That's where we live, so that's the more important number. Is La Nina causing any cooling? We have an ENSO neutral conditions at the moment in the Pacific Ocean. La Nina should be in full force by September. And you can see in the map here there's a little finger of blue, i.e. cool water off the west coast of South America. That's the beginning of La Nina. So that will cool global temperatures a little bit, but will it more than compensate for the warming that we're getting from the greenhouse gases? It doesn't look like it, at least over the long term. The problem is that carbon dioxide continues to rise in our atmosphere. It went up 3.27 parts per million in the last year, and you can see the plot here. 3.27 is nearly twice the rate it was rising 4 or 5 years ago. So that's very worrying that we're not curbing our carbon dioxide output. And one wonders where most of this carbon dioxide is coming from. We can have another measure of how much the Earth is cooling by looking at the snow and ice around the globe, and that continues to disappear. Northern Hemisphere snow and ice plotted here for June. You can see that it has a continuous slide over the last 50 years. A similar trend in the global sea ice, although that was fairly stable for the first part of those 50 years, but over the last 20 years has dropped quite significantly. And that's mainly because of the Arctic, but also now the Antarctic is beginning to lose sea ice faster than it has before. Remember that plot by Akusufu? Well, I've put where we actually are now with this red star. And you can see, unlike the prediction of Zarkova and Akusufu, the temperatures did not go down for the next 20 years. They've continued to rise and rise quite significantly. So their prediction of the global temperatures has been way, way off. So let's draw some conclusions from the Earth observations. The grand solar minimum hypothesis fails again. The Earth is warming, not cooling. None of that warming has anything to do with the increased solar activity. The current warming started before the solar activity increased and still following the heating due to increased greenhouse gases. So the overall conclusion about the grand solar minimum hypothesis is it is an epic fail. So thank you for watching. So until next time, stay safe and goodbye.